Hello, my name is Pavlo Golub. I'm working for Cybertech as a senior consultant / developer. And today I will talk about programming language, Go language, which is young enough but strong already. And I want to tell you not about the language itself, because you can read it in the manual, and I want to tell you about my passion about it, why I choose it, because I'm a little bit conservative man, and to switch the language or technology, I need a reason for that. Couple of words about my company. Probably you heard already the funny stories from our CEO, Hans-Jürgen Schönig. We are a worldwide company, but if you want to hear one more funny story, just ask Hans about the Mauritius office. Some of our clients, some of our services. And if you don't know, the PostgreSQL is still the most advanced database in the world, and that is why. Okay, so today I want to introduce you to the Go language itself. I want to tell you about the integrated development environments and tools available for this language, the drivers we should use, what exactly useful extensions we have here. We will talk about the ecosystem around the Go language. And later we will cover the testing, the testing process for Go programs. And if we will have some time later, I will try to make a demo. Okay, so I list here some reasons why the Go is not the worst. I mean, it's a good choice. First of all, it produces the native binaries. For every platform you have, you got the one and only binary, and you can build it on any platform. Meaning, if you are working on Linux, you can still produce binary for every output platform you have. Meaning Windows, macOS, etc. Even Android, whatever. The Go language itself is very simple. And that means that one can learn it in a couple of weeks. It's really fast. I mean, it's a fast compilation. It's not like C1, so you can use it not only on your local machine, but also on the cloud environments, which is really cool. It has a rich standard library. It has powerful concurrency control, not only with the mutexes or critical sections, but also with channels and messages. And it's really easy to learn. It looks like C probably, but it's really easy, just for me. And it has a very comprehensive tool set. I will show you some of them later. Here, the slide with some of the results of the survey in 2020 made by the go.dev portal. So the question was, in what area you are using Go language? And the mostly 70% was about web programming, and the half about databases. And the real thing here is that desktop GUI, 9%, but the thing is that the Go language itself has no GUI library, and I'm wondering what that means, really. So, here are some products, well-known products written in Go language. First of all, it's Kubernetes. Then it's Moby, Hugo. Probably you know the framework for building static websites. Grafana visualization platform, etcd, key value storage, and so on. But what about PostgreSQL world? This order is by the number of stars on the GitHub. So I just filtered the projects connected with PostgreSQL and with the Go language and rated by star count. So the first one, the PG Web, is a client for PostgreSQL. Stolon is a cloud manager. Then two separate operators, one by Zalando and one by Crunchy. WalG, archival and restoration tool. PG Center by DataGrid. Then PG Watch, monitoring tool by Cybertech. PG Timetable, scheduling tool by Cybertech, written by me. And the funny tool, PG Flame, which allows you to represent the explain output in the form of flame graph. If you want to find more projects written in Go, you can visit the link here. There are a lot of them. So what exactly IDEs and tools one should use nowadays? Again, let's see on the results we have in the go.dev survey in 2020. So the 2021 results will be available in March of the next year. And I think that this code will dominate. But right now, we already see that 40% of developers use VS Code as their default IDE. Then we have Golang and IntelliJ by JetBrains. By the way, JetBrains released new lightweight IDE called Fleet. I didn't try it yet, but I think that this is the answer to the VS Code domination. We will compare them later, maybe. Then we see Vim, NeoVim, Emacs, and others. So what about my environment? I'm using VS Code because I tried to use JetBrains product because I used a Python IDE, PHP, and WebStorm before, but I didn't like it. The debug process was cumbersome, and VS Code is working smoothly without any issues. I added GoTest utility, which just the Go test with colors. So it uses some coloring of the output of the test running. Then, of course, I'm using linters. Here it's a Golang CI lint. It's not a linter itself, but it's a linter running. So you just say what kind of linters you want to use for your project, and it downloads it and run it against your code. Very handy. Tab 9 is the plugin for artificial intelligence code completion. Go Releaser is the utility to produce binaries, packages, and all this stuff from your code. I use it locally just to test if everything is okay with my code. But for the releases, we use GitHub Action and the standard action with the Go releaser. Of course, I'm using PostgreSQL as a testing target. And this Gitpod.io site, I found it 2 weeks ago, and it's extremely cool feature. I never thought that I will be so excited about the container-based, cloud-based, ready-to-code developer environment. So you as a developer, describe what exactly environment you are using for this particular project, and later, any person who is opening your GitHub repository clicks the button, and the same environment is opened in the browser with the same tools, with everything, and they can proceed, they can program, they can test your code within their own browser, even they never knew about Go language or PostgreSQL or whatever. So this is just ready environment in their browser. In our projects, we are using GitHub integrations. I'm sure that the GitLab and Bitbucket have their own integrations. I just never try them. So the first one is a dependabot. This integration checks automatically the dependencies. You have the versions of the dependencies your project has. So for example, if some library is updated and you didn't notice that, then this bot will create a pull request in your repository, allowing you to check compatibility, what's new, the full changelog. It will run all tests, and later you can decide, do you want to update your code to use the latest library, or just postpone it later. Another action is a CodeQL. This action provided by GitHub runs some tests to analyze your code for security vulnerabilities. It's young for a Go language, but it's mature for C and other languages. Our own actions are usually divided in 3 categories. First one is a build and test, which must be executed after every commit or after every push or pull request. Then we have a special GitHub action called release, which will run the Go releaser, will produce the packages, will collect the changelog from the commits, and will produce the whole this release stuff. It allows you to notify some communities on LinkedIn, or send notification to the Telegram channel, or a lot of. And the last one is the Docker action. It runs after every push. So it produces the Docker images for every branch, including master and every branch we have in our repository. So if you want to provide some quick fix for your client, you just provide your client with the link to his Docker image, and that's it. You have immediate response. Now about drivers. First of all, I'm not a fan of the ORM. I think that it's not a pure evil, but I don't see the reason why we should use it, especially when people are ignoring the SQL itself. I can understand when there is a choice behind it, but nowadays, from what I see, every young developer just starts from the ORM and do not understand the database behind it. That's not good. Okay, so about drivers. The Golang idiomatic way of working with databases is the database SQL package, which is just a set of database access interfaces, meaning that there are a bunch of methods which we will use to work with a database. To actually access the database, we need some underlying driver. For example, for Oracle, it would be one, for MySQL another, and for PostgreSQL, nowadays we have two drivers. First one is libpq, and another one is jackc pgx. Standard de facto libpq was long enough with us, but right now it's in maintenance mode and no new features added. And so if you want to go with the new project, you certainly need to choose PGX driver. Plus, a PGX driver can work in the compatibility mode with the database SQL. So if you need some specific components of your application still working with the standard database SQL packages, you can still use PGX, but with the special standard lib package. So how should we choose where to use the standard approach with the database SQL, so idiomatic way, or using PGX? PGX meaning that it was created specifically for PostgreSQL, as we used to in C library libpq or some others. Meaning it's not using the mindset of a Go language, but rather the mindset of a C library. So if your application is targeted only against PostgreSQL, and there is no any other components of your system that can depend on the database SQL package, you should go with the pure PGX. But if your system is complicated enough, or you need to use this bunch of interfaces provided by the database SQL, you still want to use PGX library, but you want to go with the special adapter PGX standard lib. Why I want to use the PGX library without the database SQL standard approach? First of all, PGX supports all and every data types of PostgreSQL. It does automatic statement preparation and caching. It can use query batching, a lot of funny things, and most of them. So for every standard type, it uses binary format, meaning that your traffic is less than in case you want to use the text representation. Then it supports copy protocol natively without any issues. But if you want to use copy protocol in within the database SQL approach, you cannot do it easily. You can do it with some kind of magic, but I don't recommend it. Another functionality of PostgreSQL which is implemented natively is the listen notify. You cannot do listen notify using the database SQL or libpq. And of course, native support for HStore, JSON, JSONB, and large objects. Okay, so how these approaches are different. If we were using the standard database SQL package, we are starting from the importing database SQL package in the first line, and then we need to import the implementation, the driver itself. And this is, you can see in the last line of the import clause, we are importing PGX standard library. And then we do the usual simple things. We are calling sql.open. We are using PGX protocol instead of Postgres in case of libpq. And we have database, DB object, and we have error. DB object is not a connection itself here, is the pool of connections, because that's how the architecture of the database SQL package is written. So right now, after the error checking, you can run a lot of parallel workers, and they all can use this DB structure simultaneously, and this DB will produce a physical connection to database each time it needs it, and will free it or close after some timeout. If we want to talk about libpq, so the way it was that if you call, after you call SQL open method, there was no physical connection made. Just pool was created, but not connection made. And usually developers were simulating it by sending some simple query, just like select one or just semicolon to force the pooler to open the physical connection. Why is that important? Because you want to know if your credentials are correct or not. In the case of PGX, automatically after the pool creation, the ping is sent to the server, and we know immediately if the connection is established or not. Nothing complicated after that, so we are just using DB, we are querying the row or querying the rows, and we scan values. So very easy. In case of PGX pure connection, we are not using the database SQL package anymore. We are using native PGX approach. And here, the connection, the con object, is the real physical one connection to your database. It's not pool anymore. So you cannot use it simultaneously from many parallel workers. You need to split it using, and that's good for some applications. If you need just one connection, you're fine. Nothing bad with it, but you need to remember that the PGX library creates a physical connection, a real connection, not a pool of connections. As you can see that the code itself is pretty much the same as previous one, except we use some context which we are passing to the methods, which is very convenient way of signaling the PGX library that we want to kill something. If our context is timeouted or is not valid anymore, we just can immediately close the connection, go out, and do whatever we want. There is no need to signal somehow But if you want to use the pool, there is special package in the PGX set of packages, a pgxpool. So the same approach here. Instead of pgx1 physical connection, we create a pool of connections calling pgxpool.connect method. And we're working with it the same way as in previous situation, but we remember that this is the pool of connection, and we can pass it to the several workers in parallel. Okay, so about useful extensions. I think that people are choosing ORMs because they are lazy, first of all, and the second reason is it's too hard to serialize, deserialize values from and to database. And in this case, we have this gmoiron SQLX package, which is very handy. It's written especially for database SQL standard package. It enhances the standard objects, standard interfaces with some special methods, just like must open or must exec, meaning that must, if something is happening inside this function, we do not produce error, we just panic and kill the whole application. That's not the way programs should work, but maybe somehow. Another, and in this SQL's package, I think that most important methods are the get and select. Let me show you an example how this works. So let's imagine we have a structure called place, and we want to fill this Golang structure with the database values. So we have country, which cannot be null. We have city, which can be null. We're using special type for it. And we have a telephone code, which has telcode name, telcode column name in the underlying table. And we can tell our package that we will use this column name. So what we do here with SQLX, we are calling a special method called queryX. It returns enhanced rows or row object, which has this pretty method struct scan. So you don't need to enumerate every column and get every value and check for a name, check for a null, check for a correct notation, anything. It will do it for you. In this example, we are using the same place structure described earlier, and we want to use slice of these place structures, so several of them. In this case, we just can get, we can use SQLX method get. So if we have just one row and we know about it, it will fill our structure immediately with all values we have returned from the database. If you know that we have more rows, we can use select method, which will fill the slice of the objects with the information from rows we have. And we can not only use the structures with these methods, but ordinal types, just like integer or string or slice of strings. So we just, if you want to know the count, we can put the result into the integer. If we want to have a list of names, we just can select it to the slice of strings. And it's very convenient. For PGX, there was no such a library, and that was not very convenient. But maybe a year and a half ago, there was developed a package called scany, which do the same thing as SQLX is doing for a standard package, but the scany thing is written in more abstract way, so you can make it work with any kind of database-like interfaces. And one of them is, of course, PGX. So as you can see, the semantic is pretty much the same. We are using select method to obtain the slice of objects. Okay, so here we go, testing. There are several approaches for testing. One would be to test your code against the real server. Another one would be to use some mocking libraries. And the third one is to mock not the server, but mock the protocol of the server. This is very rare when you want to do this, but there are some libraries that allows you to do that. For example, the pgmock and the cockroach Go. As you know, cockroach is written in Go language, and it uses the PostgreSQL wire protocol. So there is standard cockroach Go testing server, and we can use it for our applications too. The most convenient and the most usual way, I think, it's using the mocking libraries. There are two mocking libraries on the market for PostgreSQL database. If you are using standard SQL package, you should go with Go SQL mock. And if you're using PGX, you probably want to try my pgxmock, which is the same approach to testing as a Go SQL mock, but written specifically for PGX. How we do testing? First of all, we want to describe the interface. We will use why that, because we don't want to use the real connection, the real server, but we want to pass instead of the real server our mocking library. That's why we are defining the interfaces, and the method of our mocking library are the same as the methods of our native package. Then we have some kind of, I don't know, function for testing. We want to begin transaction, then we want to update something. If everything okay, then we want to insert something. If we got the error, we want to roll back. If everything is okay, we want to commit. Usual situation, nothing special. How should we test it? As you can see, our record starts function accepts the pgx iface interface as the first argument. So the trick is that instead of the real connection, instead of the real pool, we will pass our mocking library. As you can see, we are using pgxmock. We are creating the new connection, new mocking connection, new mocked connection. Then we are trying to describe to our mocking library what we are trying to achieve. So we are expecting begin, we are expecting the start of transactions, then we're expecting update, and we want our mocking library return some result. Then we're expecting insert statement, and we want our mocking library to return some result, and then everything okay, we are expecting commit. This is one scenario, positive scenario, successful scenario. Then we want to check the results of this test. Just like we are calling our record stats function, there is error, we failed our test. If the last line, mock expectations were met. So this line tells the mocking library to check if all of statements we are expecting for are executed. For example, if we execute just update and we commit, there is no error, but our logic waits that there should be one more statement. And in this case, our mocking library tracks if all statements were executed and if some of them were not, or some parameters differ, then that will produce an error. And the unit test case for a fail, pretty much the same, but we are telling that, okay, if we are expecting insert with the arguments 2 and 3, instead of some result, let's produce some error. And after we produce some error, we are expecting rollback. So the same here. We are calling our record stats function, but now we are waiting error. It should return error. And then once more, we are checking if all of our expectations were met. Okay, so what we have here. First of all, Go is a popular and language. It's easy to learn. It's well scaled. It's young enough. According to the Hired portal, Go is considered to be the #1 most in-demand coding language, according to the 2020 survey, probably. As you saw, half of developers use Go to work with databases. You can use whatever editor you want, whatever IDE, it's fine. And as soon as Kubernetes is written in Go language, probably every operator for Kubernetes will be written in Go language as well. We see it just like an examples for operators for PostgreSQL by Crunchy and Zalando. And I think that will make Go language even more popular because Kubernetes is extremely popular nowadays. Go is very flexible. You can use whatever driver you want. libpq is still working, but it is in maintenance mode, so probably you want to start with the PGX. We have a powerful tools and integration with the most famous source control, services, just like GitHub, GitLab, and Bitbucket. And the cool thing about Go language, it's backward compatible. So the API may grow indefinitely, but there is no chance that the first release, the first version of Go language will be broken by these new versions, and that's very cool. If you have any ideas, please let me know about them. You can find our projects in our GitHub Actions, in our everything about the Go language and on our repository. And you can find pgxmock library on my repository. Thank you very much. And if you have any questions, I can answer them. And if you want, we can try to do some demo with this Gitpod.io thing. And I will show you how to spin up the development environment in the cloud with the PostgreSQL on it, with the tools on it. Okay, I knew that. How much time do we have? 8 minutes. So, okay, do you know what happened when you press in dot button on GitHub repository?
Which button?
Dot. So, okay, right now we have PG timetable repository opened, and I will press the dot button, and automatically GitHub is opening the github.dev environment in which the VS Code browser version of VS Code is available, and you can start, edit, and investigate the project right away without waiting for, without knowing how it operates or whatever. The only drawback here is if I want to use a terminal, it's not available. And that's why we want to use the Gitpod.io. As you can see, I have a special Gitpod green button here, which means that if I will hit it, we will open our Gitpod environment right away. So let's try to do that. I hope it will be fast because I used it not so long, and there must be some pre-built image to load fast. Meanwhile, I will show you how that works. So in our project, we have two files, Gitpod YAML and Gitpod Docker file. Gitpod YAML tells, can you see? Gitpod YAML tells our Gitpod.io service what exactly environment to use. First of all, we are saying that we want to use special image which is stored in our .gitpod.docker file. Then we want to describe tasks which should be run on the start of our environment. Right here, I'm using the PSQL to create some user for testing purposes and to use the database for testing purposes. And as a last task, I am just checking that everything is okay and the Postgres is running. Next task is I'm trying to install the Golang tools I need for this. Here is Raquel Go test. Then I can tell what exactly extensions I want to add to the VS Code. Here is the Golang extensions. And the last part is, in the last part, I can describe what ports should be open. For example, if I'm using some React application or some, I don't know, web UI, what ports should I open to be able to debug, to interact with this environment? So the Gitpod itself has the Docker file for PostgreSQL, but it's outdated. It is using the standard Ubuntu package, which is 12 right now. And that's why I decided to write my own Docker file. First of all, I used the installation instructions from the PostgreSQL.org. Then I start my server. I'm checking if it's available. Then I want to create some users before that. Then I want to create a database for these users. The user git pod is the default user for the development environment. That's why I want to create a PostgreSQL user git pod so we can log in immediately without adding some users or rules to the pgxmock file. And what we have here is our environment. We have terminal here. Let's start to connect to PostgreSQL. We are in. Can you see it? Let's try to know the version of it. It's 14. And we have all of our source files here. For example, let's check gitpod YAML. And the most interesting part that we can spin up as many these environments as we want to. For example, if I have several issues in my repository, I can spin up several environments, and each of them will check out its own branch with this issue, so I can work simultaneously on the several branches, and later I can use the VS Code source control to update, to commit my changes, and to produce pull requests, etc., etc. And another way of using Gitpod.io is the training purposes. So, for example, I want to show my colleague how I work with this project, or how to fix something, or how to do something in the project. Instead of setting up the whole environment on his machine or her machine, I'm just providing the link to this environment in the cloud, and we are working on the same environment, on the same source base simultaneously. And I think that's very cool. Thank you.